A barrel of crude oil costs about $55 today. That same barrel, after it passes through a refinery, generates products worth roughly $80. The $30 gap seems simple until you realize what has to happen in between. We're talking about a process so precise that a single degree of temperature variation can cost millions. So capital intensive that building a new facility requires decades of planning, and so complex that the machines running it never actually stop. Not for maintenance, not for holidays, not ever. This is the refinery business, and it turns black sludge into the fuel that moves civilization. Right now, somewhere in the Permian Basin, a drilling rig is pulling crude oil from 2 miles underground. The oil doesn't sit there waiting. Within hours, it's loaded into pipelines or tanker trucks, beginning a journey toward one of the 132 refineries operating across the United States. Some of these facilities process 800,000 barrels every single day. Others handle less, but the principle remains identical. Take hydrocarbons in their rawest form and break them into pieces the market actually wants. But here's what most people miss. Refineries don't just separate oil. They redesign it at the molecular level. Crude oil arriving at a refinery contains thousands of different hydrocarbon molecules, each with its own boiling point, density, and chemical structure. Some are light and valuable. Most are heavy and nearly worthless in their natural state. The refinery's job is to take that mixture and perform an industrial magic trick, turn the cheap stuff into expensive stuff. And the first step in that transformation happens in a tower you can see from miles away. The crude distillation unit stands 60 meters tall, a vertical column of steel where temperature does all the work. Crude oil enters at the bottom, heated to somewhere between 350 and 400 degrees Celsius. At that temperature, it vaporizes. The vapor rises, and as it climbs, it cools. Different molecules condense at different heights based on their boiling points. The lightest fractions, things like gasoline and liquefied petroleum gas, float to the top. Heavier products like diesel settle in the middle. The thick, stubborn residue that refuses to vaporize stays at the bottom. This is called atmospheric distillation, and every refinery on the planet has one. It's the foundation. But it's also just the beginning, because what comes out of that tower isn't finished product. It's raw material for the next transformation. Here's where it gets interesting. The heavy fractions at the bottom of the distillation column are worth almost nothing. Thick, dense, full of sulfur and contaminants. You can't sell it as fuel. You can barely give it away. So refineries crack it, literally. They use heat, pressure, and catalysts to break those massive molecules into smaller, lighter, more valuable ones. The process is called fluid catalytic cracking, and it's the reason refineries print money instead of just breaking even. The FCC unit works like this. Heavy oil flows into a reactor where it meets a fluidized catalyst, a powder so fine it behaves like a liquid. The catalyst circulates continuously between the reactor, where cracking happens, and a regenerator, where carbon deposits get burned off. This circulation never stops. The unit runs 24 hours a day, every day, converting low-value sludge into high-octane gasoline. And because the catalyst keeps moving, there's no downtime for replacement. The system is self-sustaining. Now, you might wonder why this matters. After all, we're just talking about industrial chemistry. But here's the reality. In 2023, U.S. refineries produced an average of 45 gallons of product for every 42-gallon barrel of crude oil they processed. That's a 6.3% processing gain, and it happens because the products leaving the refinery are less dense than the crude that entered. Volume increases even as molecules get rearranged. That gain represents pure profit margin expansion. But the economics only work if you understand scale. Refinery vessels follow a mathematical principle. Volume increases as a function of the cube of the radius, while surface area, which determines cost, increases as a function of the square. Translation? As refineries get bigger, their production capacity grows faster than their construction costs. This is why the world's largest refinery, Reliance's Jamnagar facility in India, processes 1.24 million barrels daily. At that scale, efficiency isn't just an advantage, it's the entire business model. And speaking of scale, there's something happening in Texas right now that hasn't occurred in nearly 50 years. A brand new refinery is about to break ground. The first greenfield project in the United States since the 1970s. America First Refining plans to build a facility at the Port of Brownsville specifically designed to process light shale crude from the Permian Basin. The project represents a $300 billion deal over 20 years, and construction starts in the second quarter of 2026. Why does this matter? Because building a new refinery is almost impossible. Environmental regulations make it cost prohibitive. Capital requirements run into billions. Public opposition shuts down permits before ground breaks. And yet, here it is. 168,000 barrels per day of processing capacity specifically engineered for light shale crude from the Permian Basin. Production could start between 2028 and 2029, and the facility will occupy 300 acres leased at the port. The economics only work because of what's underneath Texas and New Mexico. Light, sweet crude that flows easily and requires less intensive processing than the heavy sour crude most existing refineries were designed to handle decades ago. But before any of that crude reaches Brownsville, someone has to pull it from the ground. And that process starts thousands of feet below the surface, where ancient organic matter compressed under heat and pressure for millions of years. Modern extraction uses horizontal drilling combined with hydraulic fracturing. A well bore drops vertically, then curves 90 degrees to run horizontally through the shale formation. High pressure fluid cracks the rock, releasing oil that flows into the well. A single pad can access multiple horizontal laterals, draining reserves across several square miles without disturbing the surface. The Permian Basin alone produces over 5 million barrels daily, and most of it moves through pipelines to refineries that weren't built for it. That's the gap America First is betting on. Older refineries were configured for heavy crude imports from Venezuela, Mexico, and the Middle East. They have coking units and hydrocrackers designed to handle thick, sulfur-laden oil, but light shale crude doesn't need that level of processing. It's already closer to the molecular profile refineries want, so a facility purpose-built for it can skip the most expensive conversion units and still produce premium fuels. Lower capital costs, higher margins. That's the thesis. Now, let's talk about what happens when crude oil, regardless of its source, enters the refinery gate. The real money gets made in the gap between what you pay for crude and what you sell in finished products. That gap is called the crack spread, and it's the lifeblood of refining economics. In early 2025, Gulf Coast crack spreads averaged around $28 per barrel. But by late 2025, they'd compressed significantly as global inventories built up and demand softened. Refineries that once printed cash found themselves optimizing for profitability instead of volume. Crude oil costs typically account for 80 to 90% of total refining expenses. Everything else, labor, utilities, catalysts, maintenance, sits in that remaining 10 to 20%. Variable costs alone run about $20 per barrel, depending on utility prices and financing conditions. So, if crude is trading at $55 per barrel and your crack spread is only $20, you're looking at margins that barely cover operating costs before factoring in capital depreciation and debt service. The math gets tight fast, and it's getting tighter. Refinery margins dropped roughly 50% in 2024 compared to 2023, and they're down 60% from 2022 peaks. Downstream earnings for integrated oil companies collapsed accordingly. Some European refiners announced closures. Others reduced runs. The U.S. saw 400,000 barrels per day of capacity shut down in 2025, with another 120,000 barrels converted to renewable fuel production. California led that trend, and total U.S. refining capacity is expected to contract by about 3% as operators chase efficiency over expansion. Meanwhile, new capacity came online abroad. Kuwait's Al Zour refinery hit full capacity at 615,000 barrels daily in early 2024. Oman's Duck refinery started operations at 230,000 barrels per day. Nigeria's Dangote refinery ramped up to 650,000 barrels daily, becoming Africa's largest. All of this added supply in a market where demand growth stalled. Distillate consumption in the U.S. dropped 6% year over year in 2024 and sits 8% below 2019 levels. Gasoline and jet fuel demand remains 6% under pre-pandemic benchmarks. Manufacturing activity declined. Biofuels replaced petroleum-based diesel on the West Coast. The structural shift is real. Refineries are responding by pivoting toward petrochemical integration. Instead of just making fuels, they're producing chemical feedstocks like naphtha, propylene, and aromatics. Demand for plastics, synthetic fibers, and industrial chemicals continues growing, even as fuel consumption plateaus. Integrated refining and petrochemical complexes diversify revenue streams and improve margin resilience when crack spreads compress. Digital tools and artificial intelligence are enabling cost reductions of 40 cents to $1.45 per barrel by optimizing everything from maintenance schedules to catalyst usage. It's not glamorous, but it's survival. So here's what you're looking at. An industry built on century-old principles facing a decade of structural contraction. Refining capacity expected to shrink 10 to 30% depending on region. Margins compressed by surplus supply and weakening demand. And in the middle of all that, One new refinery breaking ground in Texas, betting that American shale and strategic timing create an opening no one else saw. The oil comes from the ground, gets cracked into valuable molecules, and ships globally as finished product. That's how it works. That's how it's always worked. The Brownsville project breaks ground in months. Production starts in 3 years. And when it does, light shale crude from West Texas will flow through brand new pipes into a facility that didn't exist when the wells were first drilled. The oil gets separated, cracked, treated, and loaded onto ships headed for markets that don't care where it came from. They care what it became. That's the refinery business. You take molecules nobody wants and turn them into molecules everyone needs. The margins are thin now, tighter than they've been in years. But the process doesn't stop. It can't. Because somewhere right now, a tanker is unloading crude at a dock. A distillation tower is running at 380 degrees. A catalyst is circulating through a reactor. And a finished product is rolling out the gate worth more than the raw material that entered. The gap between $55 and $80 is where the entire industry lives. And as long as that gap exists, refineries will keep running because the world still moves on what comes out the other side.